This is an R5 and this is an R6.
We're here with Danny Glad and we're going to show you everything you never knew about Dodge's small block NASCAR engines.
How y'all doing? My name is Danny Glad. I've been building engines all my life. This is all I've ever done. I was fortunate enough to be in on the early development of all the Dodge when they came back to the Truck Series and then on to the NASCAR Cup Series. Arrington Performance in Martinsville was really the point people when we first started. And then they got Evernham and Chip Ganassi and a couple other people on board. We had a pretty good core group of guys. Joey Arrington, myself, and the Dodge engineers. There was a lot of really good Dodge engineers. We started from the ground up building the race engine in the Truck Series with the small block that's similar looking to like a 340 or a 360.
You know, Glenn, I think one of the big stories in this resurgence of Dodge, if you will, is that not that long ago they might have been 40 or 50 horsepower down to everybody else, but their engine program has really come along here in the last couple, 3 weeks, really.
We ran that in the Truck Series for a couple of years. Then Dodge designed a new motor, and we helped develop it, and that was the R5P7.
Be a popular victory.
How about these two guys? Oh man, I'm telling you, they've made my life. I'm telling you, it was you can't ask for a better weekend. They did a great job, both of them.
And then eventually went to the last motor they had, with an R6 P8 cylinder head. We'll take you through all the little nooks and crannies and try to uncover some stuff that you've probably never seen before.
So we got 4 different platforms here. The factory one, the first one, the second one, and the most recent one.
Correct, that is correct.
Okay, so which one of these are we looking at right here?
Okay, this is a 340 block. So this would be the same block that would come in like a 1970 Challenger.
So after the big block stuff went away in NASCAR, if there were Mopar teams left, they had to use
this
that.
is the factory production block. Basically was all you had to work with. You know, you had to put the 4-bolt splayed caps on it, and of course sonic a block and find one thick enough, and that's what you had to work with. You know, it was a whole lot of work went into a factory block to make it work. Chrysler or Dodge, they knew that they had to do something because, you know, this couldn't handle the horsepower no more. So they come up with I'm sure there was an iteration R1 and R2. I know that I've seen some R2 blocks, but the one that was kind of sorted out all the issues was the R3 block. This block, you know, 4050 bore, 4060 was about all you could get out of it. So when they made the R2 and R3 block, which is what this block is here.
That Bob Keselowski told me that has really helped that. They're working on some new cylinder heads and some new engine blocks. These engine blocks that they're running now are basically the same engine blocks that Richard Petty and the Dodge guys ran back in the 70s. They've had to use the old molds, the old foundry to build new blocks, and they're now starting to get those, so they're able to do a little bit more R&D to the engines now to find out what makes them go a little bit faster. So if today is any indication, boy, Dodge might have something for these guys for the rest of this year. They're only giving away about 15 horsepower now on a short track like this. If you're hooked up through the corners, you can do without that.
They fixed a couple issues. First thing they did was to shorten the deck, because this was a tall deck block, and they shortened the deck to 9 inches. And then another thing they did is they corrected the lifter angle. Normally the small block Dodge was 59 degrees. This wasn't pushing in a straight line, and it lost a lot of motion. So when they went to this, and they went to 47 degrees, and the later ones were 48, where the pushrod was a lot straighter, and the action was, you didn't lose no motion in the action. You know, it wasn't disjointed, it was a straight push. So we fixed the lifters, shortened the deck to 9 inches, and also the cylinder walls were thick enough to go to a 4200 bore. And then when we went to the 4200 bore, that opened up a lot of options on your cylinder head. Now you didn't have to stay with a 2 inches and 20 thousandths valve. You can go to a 2180, 2190 diameter intake valve, which really opened up the flow. And you couldn't put that big a valve with a 4060 bore. It had to be like a 4200 bore. This is a W2 cylinder head. This was the performance cylinder head that Chrysler offered, and it was used a lot in a lot of drag racing, and an unported version was used in a NASCAR late model stock. This is what there was to race if you was going to race in a NASCAR series back when they used to run a, like a old bow tie head on a Chevrolet, probably in the 70s, This is what you ran if you was going to run a Dodge. This was their performance head. Back then, it had, the materials weren't, besides we didn't know better, but the materials weren't good enough to make smaller valves and smaller stems. But you can see here, this is a current valve like we run now. That's a 6mm stem, and you can see the difference. This one's 11/32. This is what we would have run years ago, and this is what we currently run right now. This is the same valve that you would run in a Toyota race cup motor or a R07 Chevrolet or even the Fords. They're pretty much all now 6mm stem on the intake. They run a 7mm on the exhaust because it's a little more robust. When we went to the R3 W8, where we went to the bigger bores, we talked about we could run a bigger valve. So here's the valve you were stuck with before on a small bore motor compared to the 2180 valve that you can run.
That's a massive difference.
Yeah, it's a big difference. Yeah, it's unbelievable.
So when Dodge joined the truck series, this is what they were using. This
is what we were using. Yep, this is the head we were using, and it was a really, really good cylinder head. This one here has you can look. Even back then, this one had 7mm valve stems in it. Now it's got 5/16 exhaust and 7mm, but it has a lash cap on it.
And this is the same head bolt pattern. You could put this head on a factory Mopar block.
But what they did was, this is a 10-bolt cylinder head. Okay, you can see. I know it's hard to see because you got water holes, but you had five on the bottom and 5 on the top. You had a big span to try to clamp, and just like on the Fords, we used to have trouble. We'd push out this head gasket because there wasn't enough clamp load right here. And a lot of it goes back to the heads weren't thick enough, and they, structural integrity wasn't there. But when, to avoid all that, Dodge put an extra head bolt. If anybody's fools with an LS, the LS is the same way. A high performance LS, like an aftermarket block, a Dart block, or LSX block, has the same extra bolt hole in between the cylinders.
I was just thinking that it looked just like an LSX block.
Yep. In between, this is a cylinder, this is a head bolt hole, this is a head bolt hole, and now you've got another fastener for more clamp load, and you've got one at the bottom too. Real similar to an LS.
Really, I never knew that before.
Yep.
See, everything comes from somewhere in engine world.
That's where we went to in the truck series. We ran this. We're going to go cup racing, and we're going to develop a new motor. Because then the Chevrolets were running a SP2 engine, which was a polyspheric motor also, with the valves were candid in it.
What was the horsepower range of this versus this? Like, how much power were these truck engines capable of back then?
Okay, this motor, probably the best you could do, 580, 590 horsepower, that would be like in a cup car. Of course, drag racing with more radical cams and stuff, but what we would run in a cup car, probably, 580, 590 range on horsepower. And with the heavy valves, big stems, it was probably 78, 7,900,
So that's like, if this engine could have been built to a cup spec in the early 90s, that's all it could do.
Right.
Because it never ran in cup.
Right. Well, I'm sure the Dodge guys, when they ran a Dodge, if they didn't run a big block, you ran a small block. This is what you ran.
Oh, back in the 70s or
Yeah, this is the head
stuff.
you ran. Yeah. Yep.
Okay, I wasn't even thinking about that.
Timmy Petty and them, works at Children's. I'm sure they could shed a lot of light on what they did back then. But
well, I call that the unicorn. You're not going to find another engine like that with all the complete stuff. The bell housing, the rat roaster intake, which is all magnesium.
I didn't have much to do with it then. We get them from time to time in the shop now, but that was the W2 head. That's what they ran.
That could be a whole different video of the early days of all that.
And then so you're looking at 580, 590 with this motor, and this one here you're probably looking at 700. We went to a big bore, went to a shorter stroke, because at 358 inches, at a 4030 bore, you had to have a 500 stroke to make 358 inches. Well, when you went to a 4180 bore, you could run a 3250 stroke. The biggest driver with the stroke is, well, the big bore, it just breathes better. You can run a bigger valve and it breathes better. But also the stroke takes away all the friction from the piston going up and down, because it takes energy to move that piston in the bore. And people say, well, you know, all the big drag motors, they got, you know, they're big stroke motors, you know. But in the series, in the NASCAR, all the NASCAR engines now, every single one that races, I'll guarantee there's not one out there that has bigger than a 3.255 stroke. You know, just a little over 3 1/4, because they all want the big bore, you know, because that's where the power's at, you know, in the realm that they're working on. Now, if we was going to run at 5, 6, 6,500 RPM, 7,000, you know, you could run more stroke and make more torque, you know. But if you want to make power up high, you have to pull the stroke out of the motor.
If you're enjoying this, make sure you hit thumbs up and subscribe, because I was talking to the camera. A lot of people on YouTube think subscribe means you have to pay for it like a magazine, but it's just a follow button. And we've done videos like this on the Chevy platform and the Ford platform already. So if you're interested in this, make sure you watch those afterwards.
If you had a 3.5 inch stroke, that piston's going to go from the bottom to the top. It's going to be 3.5 inches. Well, that piston doesn't get there by itself. Something has to move it, and it takes energy to move that piston. So if you had a 3.5 inch stroke and you switched to a 3 1/4 inch stroke, and you kept the same cubic inches because you went to a bigger bore, that piston actually has to travel 1/8 of an inch less on each stroke. You know, it's 1/8 inch less top, 1/8 inch left on the bottom.
So it's a 1/4 inch times 8,000 relative to your overall piston speed.
Well, that piston doesn't get there by itself. So even if it's not on the fire, you know, the fire stroke, it pushes it down. Okay, but still, if there's drag on it, that's energy that's getting used. It's not going in the crankshaft out to the wheels. So there's a lot of power with the shorter stroke. Now, I know guys are going to say, "Oh yeah, but my motor, I got a drag car and I run a 400 or 500 stroke motor." Yeah, but you probably don't turn at 9,000 either, you know. All this stuff was geared to 8,500 and above, you know. Not this stuff, you know, this was in the 6,800, 7,000, 7,200 range, you know. But when we went to this, everything moved up. Because, you know, when you talk about horsepower, okay, torque is the number that the crankshaft actually generates in foot-pounds of rotating force. Horsepower is actually a calculated number. You take the torque times the RPM and divide that by 5252. That's a constant, and it'll come up with the horsepower number. So the more torque, the higher you make the torque, you know, because you're multiplying by the factor of the RPM, it'll make more power. So, you know, to make more power, you have to turn more RPM, basically. If you can get rid of the friction, that power that you freed up goes out the crankshaft. It's just physics.
If that particular piston is not on its power stroke, then it's being towed around by the other one that is.
Right.
Somewhere else in the engine.
That's correct. Right. And you know, years ago, we used to run, like this is an old piston, and you can see the difference, what they look like now. You can see how massive this piston is, and these rings used to be a 1/16 of an inch thick ring, and you had 2 of them, and then you had a 3/16 oil ring, you know. Well, now, it's in millimeters, but basically now the top ring is 26 thousandths, and I hear guys even going smaller now.
So even the R3 W8 setup was still using the bigger pop-up pistons?
Yeah. Mm-hmm. Well, yeah, we ended up with a flat top. We did work our way to a flat top because we got the chambers shallow enough. You can see here.
Were there multiple versions of this R3, like multiple versions of heads for the R3 block, or?
No, there was an R2, which is, I'm pretty sure that's the head they ran in like the IROC series back in the 80s, you know. And then there was an R3 that came out with the R3. And I don't think we had to run a dome on this. I don't think we did. So
It would have been interesting to see what this platform was capable of within the Cup series, because the trucks had different rules. They made less power than the Cup.
Right, they were restricted on a carburetor. Right, they had to run basically a 390 carburetor with like a unlimited booster. You know, you could massage the booster and make it real small as compared to a stock 390. You know, we were allowed to run a roller cam in them. They were 12-to-1 compression, and if I remember, I thought they might have been around 680, but I don't remember exactly. You know.
Even since the Truck Series started in 1995, 2 years later in 97, there weren't that many Dodge trucks in the field. The Pettys had a truck, Bob Keselowski had a truck. One of those trucks was the number 19 Pennzoil truck driven by Tony Raines. I think it's pretty cool. Even back then, they made an effort to have the same paint scheme across multiple series, even after Rohrig switched to Ford the following year. It basically matched Steve Park's Pennzoil Cup car with the same pearl yellow metallic paint and everything. Pennzoil's been involved in supporting racing for a long time. And if you're new here and didn't know, Pennzoil supports what we do here too with these videos. I use Pennzoil Ultra Platinum in my race car, which is a Dodge R5P7 engine that we show here in this video. We use Pennzoil Platinum or Ultra Platinum depending on what's needed in every car we have. And you should too, if you like these videos, because odds are you have a car that needs motor oil and you got to put something in it that's good. Without sponsors, race cars don't go to the racetrack. And it's our job as race fans to support the things that support things we like. So next time you go to the parts store because you need an oil change, put some Pennzoil in your car and you can feel good about it. If you do your oil change with Pennzoil, tag me on Instagram and I'll share it. So that was sort of, even though they were restricted, that was sort of the foray for Dodge to get in there and establish a program and be reliable to then build the...
It was all this... I don't know how to say, but there was a revolution in manufacturing. You know, CNC was really coming on board in the 80s, you know, and in the 90s and 95, you know. That's why we were able to make valves like this that would run 2,000 miles in a motor.
So that's the R3 block, that's the R5 block.
Correct, right. This block had the 9 inches decks, which is where this block was, 2 1/4 inch mains, which is where this block was. The main brings 2 1/4 inches. Which is a Ford size, like a 302 size. One major difference that they went to on this is, if you look here, if you notice the decks, this is a closed deck block. And this is an open deck block. If anybody's taken a cylinder head off of a Mitsubishi or a foreign car, all those are open decks. And the main design for that is to get water to the cylinder head quicker. The ideal is most of the combustion heat goes out the exhaust pipe. But there's still some that, you know, in the piston, and when the piston goes down, it gets in the cylinder walls and it's in the cylinder head, the heat. It has to get carried away. You have a solid deck like this one, and, you know, that deck is probably 400 thousandths thick on top. Well, the heat has to transfer through that deck before it can get to the water. Well, in this block, the head gasket sits right on there, and it's pulling it right out. And you're going to look at that and say, well, it looks like them cylinders would move around a lot. You know, it doesn't look like they're supported, but it doesn't. They're really, really rigid for what they are. I mean, it was really surprising when we went to that.
Now, you were around and involved in the origins of this. You didn't just show up and this is already here. You were in the loop when this was happening, right?
When we built it, right? Yep. Mm-hmm.
Now, I've heard this before, but I don't know for sure. Maybe you can clear it up for me. Did these blocks get cast in a Caterpillar foundry?
The first ones might have been. I'm not sure. I know when we went to the R6 blocks, we went to Granger and Worrell in England, and they cast them. But I'm not. I'd have to ask Pat Bear, one of the Dodge guys, really where those were cast, and we can do that and find out.
So I thought I read a story somewhere. Maybe this will help you figure it out. That they were having something with wherever they were being cast, and then because Bill Davis was coming to Dodge and had the Caterpillar thing, he connected the Caterpillar to them, and they did.
That's a story I never heard. It could be, but that was just.
I'd like to figure that out because that's pretty cool. It's like,
yeah. That would be pretty cool.
Just looking at these two here, the biggest thing that stands out to me would be the skirt rails on the bottom
to
capture the cap. So this is like an LS engine too.
Right. Yep. They went to the skirted block and cross bolted you know, there's bolts here that go into the mains to tie the main cap in. You can see one here that ties into that main cap for rigidity.
What about the oil distribution for higher RPM? What was done on this for oil management?
It came in here, which is similar to the R3. It came in here and went to this galley, which is the main feed directly to the main. If you stick a rod in here, it'll go to here, right here, you know? Now, they did the same thing with this. The oil comes in to here, and this feeds direct. You can see this passage, it goes right to there. It's direct shot. Another thing the piston has to do, the piston has to get rid of heat somehow, because that piston's in a really harsh environment, and it needs to shed the heat. Otherwise, it's going to anneal, the heat will anneal the aluminum and make it soft, and then it'll fail. That's a lot of times what happens. The pistons anneal. We hardness check all our pistons. We'll run a race and we'll hardness check the pistons, and it'll kind of tell us where we're at. We got a threshold where we can't be under, we know we're in trouble. And a lot of that has to do with timing and jetting. When we used to run the big piston, look at all the skirt you had to dissipate heat.
Yeah.
You know, the heat went in here, it went out here into the cylinder walls, and then the water carried the heat away. Well, with this, there's a lot less area that touches the cylinder wall. So the piston's going to run hotter. The next thing is a lot of the heat went out through the ring into the cylinder wall. Well, when we went to a piston ring that's 25 thousandths thick, it's not going to transfer as much heat as one that's a 16th thick. The rings we run are thinner than a spark plug gap. You know what I mean? 23 thousandths, that ain't nothing, you know?
Yeah.
So what we did, well, what Dodge did is we started running piston sprayers. And you can see when the oil came in here, it goes to the main feed. Then it comes down here, and there's another galley that runs along here. And you can see in here, piston sprayers bolted in there and sprayed the bottom of the piston.
So this little thing goes in there with an angled pipe that goes
I'm
like
going to
that.
go get one. Let me go get one.
See, this is fascinating. I like.
And you ought to see, I wish I had an RO7 apart, because you wouldn't believe how many. They run, RO7, we run 6 sprayers per cylinder on RO7.
That's crazy. I didn't know that.
And it got really important when NASCAR mandated multiple races. This was one of the original ones we did. Well, Chrysler did when I say we, but it was developed. So it's like a banjo fitting, and it gets bolted in right there. And I don't know if you can see that, it sprays up on the piston.
Yeah.
Okay, well, we had one to start. Then, we kept seeing as we started running the motors leaner, trying to get mileage and longer races. We had with 2 sprayers on it. So that went in there. And the original blocks only had one place for it. And then as in the developments that went on, they put another boss, and now we ran 2 per cylinder.
Were they this configuration by the time Daytona 2001 came around, or did this get added some point during the?
Well, even the Daytona stuff when we first started, it had one sprayer on it, And as we kind of went on, we figured out the engine temperatures keep going up because they keep wanting to run more tape on the grill, and they want it because that's free, right? I mean, that was a big player. Cooling was a big player in this, and it was really because they were wanting to run. Stop the grill up more with tape or a plate, because that's downforce and that's speed, So the engine temperatures, we used to try to be 180, 190. We was happy. When in the current NASCAR world now, 230, 240, 250 is commonplace. And now they don't even run radiator caps on them. Now they run pressure bypasses to keep the water from boiling, because it won't boil under pressure,
So are there R5 blocks running around out there that only have one of these ports in them?
Yes.
How likely are you to come across one of those older blocks?
They're around. Yeah, they're around. Yeah, there was a lot of them done that way.
Are they any structurally different than the other ones?
There was some lightning changes. There was some like there's even newer blocks that don't even have this on it. And there was some other lightning stuff done. There's some of them that doesn't have none of these bosses here put on them.
What were these for?
I think originally to bolt a motor mount to it.
Oh.
You know, if you didn't run a motor plate, it was
So-
just an option.
I didn't know that. See, I never knew that there were multiple iterations of the R5 block.
And I don't know how many of the but I wouldn't be scared to say there's 8 or 9 or maybe even 10 iterations.
Wow.
Small changes, you know. Yeah, just like we run we used to run like a Chevrolet style seal, a 2-piece seal. Then these had a 2-piece seal when we started because we had a Chevrolet flange on the back of the crankshaft to make life easy. Well, then we went to a 1-piece seal to a Ford flange on the back of the crank. If you had an early R5, it took a Chevrolet flywheel. If you had the later one with a 1-piece seal, it took a Ford flywheel.
Is the bell housing pattern a factory Mopar bell housing pattern?
Yes. Yeah, but when we went to the R6, NASCAR, in that list of stuff that we had to comply with, every motor that runs in NASCAR right now has a Chevrolet bolt pattern on the bell housing.
I think that's hilarious.
Yep.
A lot of people probably don't know that.
Yeah, yeah. Yeah, the Toyotas, Ford takes the Chevrolet bell housing, which was good. It made everything the same, you know?
Yeah.
I mean, it made things cheaper for a lot of people, right? You know, there was a lot of things like that, a lot of common things. And if you look at this block here, that was another cooling item I was going to show you. This was a takeoff what some guys did. Because if you're running the piston, all right, this is the top of the piston, this is the exhaust valve. This side of the piston runs hotter than this side, okay? So if you was going to aim your squirters, you could, you'd have one squirt, here, here, and here, and you might, and then I think this was an Evernham. It might have been a Bill Davis, but I thought it was an Evernham piece. And this went in there, and they could adjust where they wanted the oil. They're just jets.
What you're pointing out is the oil galleys are kind of similarly configured, except you can see the ridges here because this is all hogged out.
Right, lightweight. This was the start of making it light.
And did these use a chain or a belt? And this is a
Did both.
chain or a belt.
When we raced them, we raced a chain. But Dave Weber and Kent Ritter, they did a lot of drag racing development, and they did make a belt drive for this. And a lot of drag people used it. But we never did run it in the trucks. We always ran a chain, just a regular, like a double roller Cloy's chain is what we used to run. And this only ever run was a belt, never ran a chain. There was never no chain. On this motor that had a timing cover and the oil pump, the fuel pump was in the timing cover. With this one, the fuel pump is cast into the block. And on a R6, there's not even a place to put a fuel pump on a R6.
So that was electronic pump by then?
No, cable driven.
Okay.
You run a pump in the trunk by the cell, and you ran a cable either off the back of the camshaft or off the back of the oil pump. And they still run them in Xfinity. You still run a cable because you're not allowed to run an electric fuel pump. But in Cup, when they went to fuel injection, everything's electric fuel pump now and that.
Should we get one of the P7 heads out here to see?
Yeah,
Okay.
We'll compare that.
You would have never seen this engine here with the valve cover off in 2011, 2012 when it is. Look how this rocker stand is all machined out of one piece of billet. The guys that were over with Evernham and all these guys doing the Dodge, a lot of these guys came out of Indy, they came from Europe. They made this extremely stiff rocker arm stiff, and there's Tommy Wheeler, he's getting one of the other physicists in there. You can see this has all kinds of neat little stuff about the smaller balls in here, so it put less torque in the rocker arm and everything. It's a lot of things in this valve train that like they would have never let that valve cover off at the track.
No.
Today, I think just about everything looks a lot like that, or even a little better yet. Scooter talked to the guys, Davey Evaldi, and people who were over this engine, and said you've got to get your valve train guys and your cylinder head guys in one room, and they have to sit down and figure this out. And up until this engine, you didn't have the bore spacing, and you didn't have the straight push rods with the straight ports. You either had the Hemi with the straight ports and the crooked push rods, or you had the small block Ford with the straight push rods with the crooked ports. This puts both of them together. This let TRD, when they came to it, they were able to look at all the other engines because they didn't have a pushrod V8. They took a lot of the stuff on it, iterated on it, made it a little bit better. That led to the SB2 and the FR9 being allowed in, because the SB2 was R07, which really started out as the R99. The R99 was so good until these two engines came out. The R99 wouldn't become the R07, it wouldn't come out, and then the FR9 came out after that. This is the granddaddy of all modern NASCAR engines.
Absolutely.
Do you remember when the development for the R5P7 started?
It's whatever year that, you know, when Evernham started, you know, that's when we started development. Because I remember when he got his deal to do the Dodge, you know, he got a 2-car team. That's when it really ramped up, development really ramped up.
That would have been like end of 98 or something, I think, because 99 he was off and they were doing the test team and all that stuff. Or maybe that was end of 99 into...
I'm sure you could look it up.
2000.
You know? He sat on a pole the first year at Daytona, right? So
yeah.
You could look.
I was curious if you remember when it was brought to your attention that, one, Dodge is going to Cup, 2, Dodge is developing a new engine to replace the one that you've been used to working on.
When they made the decision they was going to do the Cup deal, Jack told Lynn and Eddie and them that he really didn't want me being in there seeing his Cup engines when I was working on developing a Cup engine.
So you were working on R3 Dodge stuff in the Wood Brothers shop?
In the Wood Brothers shop, yeah. Well, using their equipment basically, you know. And Lynn said that was fine, just I couldn't do no Cup stuff, you know. The truck stuff was all right, couldn't do no Cup stuff. Well, then when they decided they wanted to do Cup, Jack didn't want me, you know, he didn't want me in there no more. And I understand that. You know, me and Jack's still friends, you know, it's no problem. So I went to Joey's. But when that day happened, and I might have been 95, like 95, late, no, it wouldn't have been 95, 96, started 96, I guess.
So that's when the balls set in motion for the Cup return in R5.
Right.
Was 96.
Right. And I actually stayed and I'd done some work for Jack over there when they decided, you know, we'd done some restrictor plate development and stuff. But, you know, tried some things and did some stuff that I thought would work. And when the Cup deal come along, he didn't want me in there with his Cup stuff, which was fine. Like I said, I was okay with all that. So, but at that day, I came home to my house and I said to myself, I'm never, ever going to put myself in a position like that where somebody can control my life. You know what I mean? Yeah. My livelihood, you know? Totally. I mean, I was doing everything best I could, never made nobody mad, but he didn't want me in there just because his stuff was going to be in there. And I understand all that, but I was never going to be in a position. I went home and drew up plans and built a building behind my house. And then that's when I went on my own and started doing this stuff. I outgrowed that place and I bought this building here that we're in now. The thing, I think it was probably 96. We'd have to look that up to be sure, but I think it was about 96.
I'd like to build out a second video of kind of your lineage, like all that and how you ended up doing it.
It's pretty interesting. I mean, It's pretty interesting. Another big jump that was made with the R5P7 was the valve train. You know, this is back in the, you know, late 90s when 9,500 RPM was pretty common, especially a place like Pocono. I mean, Penske was turning to stuff like 10,000 at Pocono, you know?
Earlier in the race, he did not shift into overdrive down his front straightaway, and we saw 94, 9,500 RPMs. Listen.
That sounds good, though. I don't care what. I hope it lasts, because that sounds good.
When the architecture for the head was laid out, this metal piece is the stand. And it was held down with these fasteners here that go down. And you can see how rigid that is. You know, if you can compare it back to the olden days when you used to have a rocker stud with a floppy rocker to set on it, compared to how rigid this stuff is now, you know?
Yeah, that is like almost half captive inside there.
Right. And then the rockers were angled, and so the push rod was straight to the lifter. It was a lot of advances made at one time.
So at the pinnacle of the R5P7, how much power was that making in Cup configuration? We
learned a little bit more now. Back when we ran this, you know, we was probably in the 830 range, you know.
Like a race motor or qualifying?
No, race motor, you know. Okay. A lot of that was driven by valve train. You know, the faster you can open and close the cam. In a perfect world, if you had a cam that was open or closed, it was good. But it never survived it in racing, you know. So let me grab a valve spring, and I'm going to show you where we went from valve springs to where we are now.
Oh, that'd be super cool.
The valve goes up and down. in the motor. And the only thing that makes that valve come back up and push the rock arm back is that valve spring. If the valve was really light, it's easier to pull it back. And that was the whole idea of making smaller valves. This 6mm stem valve, titanium, 70 grams, comes back easy. But what also adds to the weight, what you have to account for is the valve. You have the weight of the retainer that goes up and down along with it that it has to push back. The rocker, the weight of the rocker, this much from here forward has to get pushed back also. That's all weight on the valve, and the spring to a certain extent. And I'm going to say probably maybe half of the spring. You know, the top of the spring does have weight to it. You know, like that's why a lot of stuff now has gone to beehive springs. If you run a beehive spring, the top of the spring is smaller, so it has less weight, and you can run a small retainer on it. You know, so it takes weight out of the valve train. But so back when we started in the 95-ish, when we started with this motor, developing this motor, this is the spring we started with. Basically, that spring right there. A company PSI and PAC, either one makes them, and this was the retainer we used, and it was made out of titanium, just like the valve, and it fit in there. And then you had to have a pair of locks. Well, these are the locks that we used here. So put it all together. Even you get near 9,000, 9,200, the camshaft had to be pretty smooth. When I say smooth, it had open smooth and close smooth. Well, the quicker you can open and close the valve, the more power it's going to make. If it closes quicker, it builds more cylinder pressure, especially on the intake stroke. So you know, you want to leave the valve open long so that, you know, the atmospheric pressure can push the air through the carburetor, down the runner, into the valve. And, you know, like a camshaft that, say, in a street car would say at 50 would be, 218 degrees. Well, these would be 270 degrees. So that's the length of crankshaft rotation that the valve is actually off the seat. The longer the valve's off the seat, the more power you can make, because it fills the cylinder more. There's also a factor that comes in is when that valve starts to close, you know, it takes time to close slowly, because if it just slams, it breaks stuff. You know, it loses, it floats, it breaks parts. And how to fix that, if you could put a lighter assembly here, you can run a rougher cam and still be able to control it, because the weight is low. You know, that's why all these foreign cars now, they turn a lot of RPM, they don't have one big valve, they got two valves. You know, when it's light, and they can take advantage of an aggressive valve train. You can look at the difference in the spring. You know, like I said, the spring has weight to it.
It looks like half the size.
Yeah, and they're both titanium, but they still weigh a lot less, you know.
Oh, yeah.
And then the retainers, look at the difference in the retainers, too, you know. Now, this is titanium. These are actually steel. That's a tool steel retainer. There again, manufacturing got better. Every time we broke a spring and you'd send it back to, say, PSI, they would put it under a microscope and look at it, and 99% of the time the report would come back, it had an inclusion in the steel.
What's that mean?
It had a speck of rust or something that was dirty in the steel when they were making the steel for the wire for the springs. Oh. It had almost like a cavity in it. Yeah. You know what I mean? And that's and under the load going up and down, it would find that weak spot and propagate a crack out of that inclusion. And 99% of the time it would be an inclusion. You know, now when steel is made, it's made in a vacuum, and there's very, very, very little bit of impurities in it. You know, just like everything else, things got better. And very rarely do we have a spring failure now.
That's fascinating. I always knew valve spring technology's come a long way, but I never knew why the old ones would fail.
Right.
That's really cool.
The 90% of the time was plus we were overstressing it because of the weight of the valve train.
On these heads, the head bolt pattern itself, is it the same head bolt pattern as the W8 head?
No, it's you know, there's still 10 major fasteners. That's pretty much the layout you got to have because the way the cylinders are. You know, there's just, you can't put one. But it does have the inners and the outer. Was
the bore spacing the same?
Yes. Mm-hmm.
Huh.
Yeah.
So it's still a factory bore spacing.
Yeah. Mm-hmm. The R6 is a 4500.
And that's what
It's wide.
the other Cup
Yep,
engines
the
were.
Toyotas, the R07 Chevrolets, the Fords, and the R6 Dodges.
So they were all mandated at 4 or 500.
4 or 500. Yep. And you had the ones on the top, and to reach those, you had to go through a port in here, put the nut on, and put a socket in there and tighten it and torque it through the intake port. Then you put a port plug in here, an O-ring plug.
Would that plug be crafted into
Yeah,
where it stops?
it
be
would
the
contour the roof of the port. Yeah.
What about the bottom of the port? How'd you do that?
It's just got a hole, and it doesn't really affect nothing. You can. It just has it's a spot face in there.
It would sort of just run over it, not really.
Yeah, we never know it. Yeah, back when we was doing this, we actually filled them in on a dyno with epoxy to try it, and there was nothing there.
Is that because when it's making the bend, it rides the top, or how does that?
It doesn't even know it's there, I guess. You know? When we went to the R6 architecture head, we put a stud in it, so you don't have to go through the roof of the port no more. We put a stud in there, and it's like it would be like if anybody builds like a big M block where it has a big block Chevrolet where you put the nuts from inside the motor.
Like in the valley?
Yep, in the valley. There's 4 studs go down in the valley, and you put a nut in the washer and you torque them.
Huh, that seems a lot easier.
Yeah.
So what's going on with these coolant ports in the R5 head?
Okay, if you can run more tape on the grill or block the grill, less grill openings, say, you know, there's speed there. You know, you watch NASCAR races today, and everybody wants to lead the race because you out front, you got clean air. As soon as another car as soon as you're here and you try to come on that car, you know, the downforce is not there no more because it's flowing over both cars. And, you know, the guys talk about losing the nose because they don't have the downforce. Another change that was made is kind of interesting is as the springs got smaller, where are you going to put a seal? There's no place to put a valve seal.
Yeah.
So what they did, engineers did, is they cut an internal groove in the guide, and there's an O-ring in there. The Dodge engineers did, and we were really, really lucky. We had a really good group of engineers. Patrick Baer and Dave Daunter and Dave Avaldi, and there was just a bunch of really, really good guys who, they were engineers, but they understood the basics. I mean, you know, most of them guys had hot rods they worked on themselves, you know, and if you got an engineer that's got practical ability, that they're really, really good. You know, I've worked with some engineers that, you know, tell you, you know, this has to be here and it ain't gonna work there. Well, that's where we got to put it. Well, it doesn't work, you know. This is an R6 cylinder head. This was the latest design. This is the style head that Brad Keselowski had on when he won a championship. The cylinder head runs at different temperatures. You know, the exhaust side, where all the exhaust and everything is a lot hotter than the inlet side. You know, just common sense. You know, you got cool air and fuel going in one side and hot exhaust going out the other side. It's different, but it looks real close. You can almost see visually right off is the valve train geometry is different. You know, more fasteners holding the rockers down, more rigid geometry. This is an R5 and this is an R6.
So the R6 was debuted in like what, 2009 or something?
That sounds right.
Like that, somewhere around there. That's when everybody kind of got their new stuff.
It's all a blur to me. You know what I mean?
Yeah.
It was, when you're in it, it was all a blur, you know.
I'm just curious of how long the R&D process actually took from this is starting to it's ready.
It was not very long.
Really?
No, it was not very long. You know, now they got computer modeling, you know, CAD, you know, computer-aided design. They can start doing stuff pretty quick, you know. Okay, so basically, when the engine's running, the water pump pushes it in the lower case of the block, comes up along the cylinder liners, and goes to the deck. It goes through the head gasket and into the cylinder head. The majority of the water goes to the exhaust side of the cylinder head because that's the important side we need to keep cool. Okay? But then on the R5 design, which was typical for all automotive engines for the, you know, 50 years, you push the water to the intake side, into the intake manifold, and then out back to the radiator. And that's the way the Dodge was done. They came up with, the water goes up through the block, in through the cylinder head, and this is a water manifold. This would bolt on, and the water would come through these here into these, and you can see on the Dodge you had two exhaust valves together, right? So there was more heat generated right here. So you can look and see this passage was bigger to flow more water. We wanted more water through the center of the head where more heat was. The back of the cylinder head, it ran a little bit warmer. In the front, you can see we put a restrictor in there. This was after the fact. You know, we put a restrictor to slow this down because we found through our testing with thermocouples, all placed in the head everywhere, that this was a cooler part of the cylinder head.
So this was a unique modification. They didn't come that way.
No, right. We did that, during the development. Some people didn't do it, some people did, But in this one on here, so the water would come up, go through this manifold, and the radiator hose would carry it back to the radiator. Why are we pushing this water across the cylinder head now to the intake manifold? And this is the hottest part of the cylinder head. It's coming across the intake side, heating up the intake track. And you don't want that. You want the air cold going into it, and we're heating it up. So what they did was pretty ingenious. Instead of routing the water through here, like is done on the R5, the water passes, what they did was they routed the water up the exhaust side of the cylinder head. So it comes up both sides. The majority of the water goes around the exhaust side, and they made these manifolds that go in under the valve cover, and the water would come up and then go to the radiator.
So there'd be two hoses that would merge and go to the radiator?
Yeah, right. And a lot of radiators had two holes in it. Two hoses went to the radiator.
Huh.
But it didn't have to take all that hot water and put it to the intake track.
Is the Ford, Chevy, or Toyota set up like this?
No.
Even now, they never did that.
No,
they go up through
They still run a water manifold in the center.
Interesting. So even in some ways, this engine has some superiorities over what's currently out there.
That is correct.
That's awesome.
Correct. That was really groundbreaking, really. That was really a big deal. Why the new engines are not done that way, why the Toyotas and the Chevrolets are not done that way, and the Fords, but...
Or they didn't have a chance to redesign since this came out.
Might not have had, right.
I wonder if the Dodge was last to the market.
Now, we hear really, really strong rumors that Honda's coming, So it'd be interesting what they're going to do, because they've got a clean sheet of paper. They have to go by the same rule sheet that we was handed, but it'd be interesting.
So it seems like the person that comes in with the clean sheet always sets the bar again, which is kind of what the R5 did. Is superior to the SB2 and the D3, which some people might argue with that, but it's my opinion from what people have told me that there were a lot of things that were better about that than what was currently out there.
Right, exactly.
They learned.
Now you can look here, if you look from this side here, Dodge still stuck with a mirror image, right? Mm-hmm. They got, and it's kind of like the stand, you got to intake, exhaust, then you got exhaust, intake, just a mirror image. But like the Chevrolet head is symmetrical, it's intake, exhaust, exhaust. But so what, on the R6, what they did to stop some of that heat is, there's drillings. This is drilled down through here. So, and then what they did is they put a bigger hole in the gasket here. They used a head gasket to do all the restricting.
And this was coming in right when the whole tandem draft era was happening and the cars would run super, super hot. Right,
exactly, right. They wanted to stay with that design, but that was, one of the things you had to deal with, the heat right here. In the gaskets, restrict, you could adjust these holes where the water went. Mm-hmm. And, as you could see here, you put a lot of water here by the exhaust, see?
Yeah.
Was a lot of water there, a little bit here, and then, you know, a little bit here, a little bit here, you know. But it was all mapped out with thermocouples in the deck of the block, and I've got a block at home that's got, I bet it's got, we broke it testing a bunch of stuff, but I bet it's got 80 thermocouples in it.
So were you hands-on in the R&D?
Yeah,
by
when
this
we did
point?
all this, yep. We would do it, we would run it on the dyno, and then we would send all the data to Dodge, and they would analyze it and tell us, you know, they would call Cometic then and make the gasket how they wanted it, and we'd go back and run it again. You know, it was a lot of development work. And then to get water across this bridge here, you know, because you had these ports here was hot. To get water across there, there's a passage drilled. You can see there's a plug right here.
Yeah.
And there's a pass. You can even see it in that headbolt hole right there. There's a hole drilled all the way, and they would adjust the gasket hole certain ways so it would be a negative pressure here and a more positive pressure here to push water through there.
Interesting.
Yeah, I mean it was really a lot of work. See how much they widened this out?
Yeah.
Compared to the R5.
So how much actual progress was there in port design and airflow from the 5 to the 6?
The cylinder heads are pretty much worked out. I mean, you know, NASCAR tells you, you know, the pierce points, and you know, like when you submit a head, they actually have plates to check it. But when you submit a head to NASCAR, see that right there? Those are dowel pins go in there.
Yeah.
And when you submit this to NASCAR, this port center line, this way and this way, has to remain the same. So you can't, like you couldn't, if you wanted to make your manifold was turning this way here, you know, the runner was coming this way. If you wanted to move this port over to there, you're not allowed.
Oh.
You can widen it, but whatever you did over here, you had to do over here. This is a fixed location, and the valve is a fixed location. Some people think that the seat needs to be, the actual where the valve actually seats needs to be a little bit lower in the head, so you have a little bit to straighten the air where it comes out. And other people want the head milled right to the 45, you know, I mean right to the 50, the seat angle. And it's just the head porter's choice.
So there's not much of a horsepower capacity or potential difference between the two platforms. This one was just engineered to be a freaking tough as a rock and take some super crazy heat.
Right. This whole thing was designed for minimum weight, maximum coolant efficiency.
Now can we see the R6 block next to the R5 block?
Yep, that's what we're looking at. Let's touch one more thing. I want to show you one thing, the difference between the R5 and R6 on a valve train.
Okay.
The stuff has really gotten stiffer and stiffer. You know, these rockers here are an aluminum body rocker arm. You know, have a roller tip and an adjuster on the back. The whole rocker in motion is a lot of weight to it, you know. Not a whole lot, but you know, but it's also not a very rigid rocker. It does bend, it does flex quite a bit. I mean, more than you could imagine at 9,000 RPM.
Because that's aluminum, right?
Yeah, that's aluminum, right. Now these rockers here, you can see this one, it's all steel. This is a steel rocker arm. And it's supported on where this has 2 bolts that hold it down to your shaft. This one here has 4 studs that hold it right down on the engine.
And the shaft is completely encapsulated instead of just the bottom half.
Right. And another thing you notice about this, there's no adjuster.
Oh, you have to shim it?
What we do is we have shims. We can put shims under here. You know, the shims do 2 things. It'll adjust your geometry a little bit, you know, to get your valve tip with your roller right. And it'll also, you can make small adjustments to get your lash. You have 3, when you do these, it's a nightmare to do the lash. You have 3 ways that you do it. What you do is you do the push rod first. You know, we zero one on the length of the push rods, and that gets us close. And then we can do some shimming here a little bit. We have a whole stack of shims. You put the shim in it, and you put this on, you torque it. And if you still got, you know, if you want 10,000 slash and you got 12, instead of re-shimming it, we we also have lash caps that go on top of the valve, a little cap, lash cap. So you'll run it on the dyno, and you'll shut it off. You go in there, check your lash, and we have a sheet we run down, and we'll, you know, what all the lash is while it's hot. We run through them all, and then we stop and we'll go and adjust them. We'll change the lash cap here. If this one needs a little more, we'll do a shim, do a lash cap, nothing, maybe a lash cap. That's how we adjust the valves on them. So this would be the push rod, would be like an LS motor or a 350 Chevrolet. It's a 5/16. This is what we run in those.
That is really serious looking.
Yeah.
That's pretty beefy.
Yeah.
It's heavier than I thought it would be relative to, but I guess this does all the work.
Yep, it does all the work, and believe it or not, you know, it goes on the back side. At one time, we used to think that meant a lot. The weight back there meant a lot, you know. But we were on a Spintron one day, and Dave Daunter was down, and we were doing a bunch of testing from Dodge, and we were on a Spintron, and I said, let me try something. I took a piece of tungsten. You know what tungsten is?
Yeah.
Mallory goes in a crankshaft.
Yeah.
Real heavy, right?
Extremely, it's almost disorienting how heavy this is relative to
How small.
Yeah.
Right. So, you know, we were talking about weight on the rocker, and you know, we were just trying to do just a down and dirty. Let's just see what the weight really does. And I clamped it to the push rod, and we did a trace without it, and then I put that push rod, and we did a trace again, and it didn't change nothing.
Really?
On that side, did not change a thing. It's that much weight, it didn't change. On the back side, the weight is way less critical. You know, from this side forward, it means everything. The budget was there to do that kind of stuff, and we learned a lot just by doing stuff like that. You know, you can see all these ribs, how all this structure is all tied together, you know?
Yeah, it's real crazy looking.
Yeah, but it's all in keeping this valve train rigid.
That's pretty crazy when you look at the R5 block next to the R3. The R5 looks like it's out of a spaceship until you pull out the R6. Yeah. This thing's got all kinds of stuff going on in here.
Yep.
What are the primary differences?
Both 60 millimeter cam, but that had 6 cam bearings, and this one has 1, 2, 3, 4, 5, 6, 7 cam bearings. So it's got more support. The camshaft's got more support.
Looks like, are they bigger lifters too?
Well, yeah, that's a 937. That's a Jessel Keyway lifter. We run them in everything, but this one here was that was just a flat tappet block before we could run lifters, that's all.
So I didn't notice before, are these coolant passages?
That's where the water goes in.
Okay.
Comes out of the water pump and goes into there. Where a regular, like a small block Chevrolet, the water would be up, ports would be up here, and it would push the water in the case up there. You know, you have no way to meter the water to the back of the block. It's just whatever got there around the cylinders. Well, what Dodge did is they put the water in like this in a tube down here. And you can see, even on the R6, this is the water passage. And I know it might be hard to see, but it's a separate cavity. It's almost like a tube cast in there.
It's like its own manifold.
Right, it's a manifold. And then down in here, which you really can't see it, but then they could size the hole drilling. So this would have smaller holes, a little bigger and bigger back here to make sure that the water distribution was the same and not just rely on happenstance that it would get back there, you know? I mean, because as the pressure went in here, you know, it would bleed it off and then have the least pressure back here, you know, as far as the delta, but it had a bigger hole so it would still put water out, you know, which was a really, really neat design. The SB2s and all that stuff, they do it with the hose, come down, they have a boss right there and they just put it right in the block.
Interesting to see, like with the whole evolution of redesigning this for maximum cooling, how the same concept is here. It just got way bigger on this one.
Yep. Here's the rear cover that goes on the back of this block. And the oil would come in, it would go in right here and go to this main galley, which would feed all the bearings. It would go to all the bearings first. And then where this block here, to feed the piston oilers, where it did it with casting, this was done, they did it in the back of the block and done it with this plate. So this passage here would come out right there, and it would go in here and put oil to the 2 lifter galleys, and then it would go down here and put it to the piston sprayers. So all the oil direction was made in here, and they didn't have to drill no passages in the block.
Would that allow you for some tunability also for just changing those?
You could restrict these. Yeah, you could put restrictors if you wanted to restrict the bottom, or we never did because the restrictor was done at the squirter. So.
Are those oil squirters cast into the block this time?
Yep. You can see them right there.
Okay. Interesting.
Same exact thing.
It looks like this cavern here is very meticulously designed, right. Except for windage.
For windage, that's right. Yep.
It's a lot smoother than that one is.
Yep.
Did it also move the distributor to the front?
Yeah, the distributor went to the front. That's right. That's another thing they did.
So notice this hole here.
Yep, distributor went to the front.
Was that mandated or is that preference?
No, you could do what you want there.
It looks like overall the R6 is a little bit shorter of a block than the 5. Is that?
But the bore spacing's bigger.
See, that's the crazy part. It's bigger but smaller. There's less wasted material on here. You can just tell there's a lot more meat on this thing than that one.
Pretty amazing.
I mean, how much space there is from the transmission flange to the back of that cylinder versus the back of that one. I mean, the close one is almost right on top of the transmission with that headbolt there.
They did entertain early on having a place they could maybe put a fuel pump, and they put a piece, cast this piece in here that they could drill for a pushrod, like this, but they never did it. Everything was cable driven.
Oh, so that's why this thing is there.
That would have been, if this was a development block. If it wasn't a development block, that would have been machined off.
Oh.
One little piece of tidbit that really nobody knows is on this side of the block here, see that RWS?
Yeah.
That was an engineer, Rudy Sane, his name was. He was a really, really, really good engineer, and he was one of the lead guys on the block, designing the block, and he passed away, and they put his initials in the block.
They all have that on there?
Mm-hmm. All the R6s got Rudy Sane on it, yeah.
That's awesome.
I don't know what his, William or Walter, I don't know what his middle name is, but yeah, Rudy Sane.
That's so cool.
Yeah, I bet that, ain't nobody knows that.
Now they do.
Now they do.
Is there anything else about any of this stuff?
No, that's really about
Nobody
it.
knows this, but I do.
That's really about it. See what we talked about, the bolt holes. See, this is flat on the bottom where you put a nut.
Yeah.
You put a nut in there and then you torque it with a special torque wrench we got. Them guys at Dodge was really, really good to work with. I mean, it would be really cool to get all them together, you know what I mean, and have them tell part of the story too. You know what I mean?
That'd be awesome.
Yeah.
You still talk to them?
Yeah.
Yeah. If you could, maybe they'll watch this if they mention that. Like, I'd love to talk to them, or wherever they are, we'll figure that out. Because really, in the war room where the decisions were made and that stuff was hashed out in the corporate decision-making process, that is really like, nobody knows that. Those things never left those rooms.
We used to go up there a lot to the Chrysler CTC, they call it the Chrysler Technical Facility. It's gigantic, this place. And I think they got like 80 dynos there, doing development work, And they had a dyno for, we would go up there and do endurance. We'd build a motor, and I'd put it in the back of the truck and take it up there. And we'd put it on a dyno and run it endurance for 600 miles.
Is that the building that you can see from, what is that, 75 or something, with the big Chrysler logo on top?
Yeah, yep. Mm-hmm. It was amazing to be a part of it, really, I mean, who's going to get to go do that stuff now? I was just a regular guy, and I got to go with them guys everywhere.
Well, I appreciate you telling us about it. I hope everybody learned something. I sure did. I mean, Dodge people know a lot of stuff about the Ford and Chevy platforms because they kind of evolved so closely with the production Windsor and small block stuff, but these were kind of like, it was like the Wild West a little bit. It was a little less known, a little less popular per se. It's not Ford or Chevy, and the more I learn about it, the more I like them, that's for sure. If there's anybody out there who is from corporate Stellantis, Dodge, Ram, or friends with somebody who works there, I'd love to do more stuff with this. And if there's some engineers or any type of stash of prototype cylinder heads, blocks, intake manifolds, valve train pieces, anything like that that was kind of part of that factory development story, I think that'd be super cool. Like, send me an email, we get in the truck and drive to Michigan tomorrow. That would be awesome. And if you enjoy this engine tech stuff, we've done a handful of engine tech specific videos, not only just covering the evolution of the Ford and Chevy platforms, but also a whole buildup of the Lake Speed's old C3 engine. I know most of you guys, the regulars, have seen that already, but there's always new people. And I got to remind you that there's several years of these types of videos built up already on the channel page. So go click on the videos tab and scroll down and find something that interests you, because I guarantee it's going to be there. And at the same time, Danny Glad in this case was merely the presenter of technical Dodge engine information, and we didn't get into his own career or story at all. And there's a reason for that, because that will be its own video at some point for sure, because he's got some great stories and he's been around for a lot. After we were done filming this, I sat there and talked to him about his time with Alan Kulwicki for probably like 2 hours, and I was camera wasn't on, but I wish it was. Some of that can't be on for that, but you know what I'm talking about. We'll get there.